Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to make it light because we are approaching probably vacations and, Valentine's Day and enjoy your like week of vacation. Most of you, I mean, I'm talking about at least here in upstate New York. But anyway, uh, I want to give you a nice session, very brief and to the point. And it's not like it's educational, but it's not part of any of your curriculum. Um, it's about a problem that we call the birthday problem. And it's so simple. It's like you have few people in a room. Should you bet that at least two of them share the same birthday? Well, you would say that depends on how many. Yeah, you would be true. So if they are like two or three, I would never bet unless I know two of them are twins, so I can try to trick them. But generally speaking, what number I should save to bet on. For example, I taught probability and statistics for a long time, and usually two per semester. So I ended up teaching probably 50 classes or something. And at the college level, you have large groups. So on average, I would say I would get 50 students per class. That's a huge number, by the way, for probability purposes. And you say, 50, there are 365 days. So why would you bet on that? Because I rely on math. It turns out that it's almost impossible not to find a match if you have 50 students. And every time I would bet my students, of course, jokingly, and I win the bet. I've never lost. So how do we approach a problem like that? I know that the majority, if not all of you, never took probability in a vigorous sense. Yeah, you took some probability, maybe in a math course, but that's not the probability I'm talking about, like more advanced, a little advanced. How can we even approach a problem like that? So I'm going to show you from the scratch, very simply, how you can find probabilities like that you think are very hard to find. No, they aren't. Let's assume, just to start the problem, we always make assumptions. So I'm going to assume we have one person in the room, and I ask you, what's the probability that two out of this person share the same birthday? I know, I'm crazy, so that's not something new. I say, of course, it's 0%. I say, you mean it's 100% we don't have a match? He said, of course. Then how would I write that? Say, write 100%. No. I want to write it in probability language. In probability language, the 100%, which we call the sure event, is one, meaning one out of, the total sum of probabilities is one. We don't write it as a percent. We write it as a decimal. So all these probabilities, when you add them, you get 100%, which is one, right? 100 divided by 100%, meaning pourcent in French, meaning per 100. That's why we call, the cent a cent, because it's a part of 100. So percent, meaning out of 100. 100% meaning one. Okay, so I can write it one, but how would I write if I have two persons? No. So better than to write a one, you would say, how many possible days or how many days in a year? There are 365. Okay, these are the chances I have. The chance that anyone coming would be born on a single day out of these 365 days. So what chances the person entering have so that this person, he or she, doesn't have a match? You say, this guy, I know he's crazy, but what is that question? Yeah, that question is saying, no matter what day that person is born on, he has 365 chances of being born in a day, and yet he's guaranteed not to have a match in the room. It's weird, right? But it's correct. So why did we write it like that? Because the next person coming, unless he was born on the same day, if I want to say what is the probability that they don't match, I say he could be born in any of the remaining 364 days. So there is a 364 out of 365 chances that we don't have a match, which is still almost 100%. How about the third? Say, subtract one. Yes, because the third person shouldn't match with this or that. So that person has 363 chances out of 365 not to have, and still very high probability. But now we have to keep doing that for any number we want. I said, let's assume I had 50 on average. So notice that the first number, when we had only one person, was 365, then with two, 364. And you see that the sum of the number and 365 is 366, right? Plus one, plus two, plus three, when we had three people. So when we have 50, I should have 316 over 365. If you multiply all these fractions, you will get the probability that we don't have any matches. None of them, his or her birthday matches anyone else's birthday. So how do we define the other events? Meaning, I may have two people having the same birthday, or three, or four, or five, or 365, which is pretty much impossible. Or I have 2 and 2, or 2 and 2 and 2, or 2 and 3, or there are too many events. You see, it's not only having two people having the same birthday. So if I pose the question like that and say, what is the probability that two of you share the same birthday? I would be incorrect. No, I should say, what is the probability that we have at least a match of birthdays? Meaning 2 people, 3 people, 4 people, or 2 and 2, as I said, or 2 and 3, or 2 and 2 and 2, or 2 and 1 and 3 and 2, and all the combinations which are humongous, right? And I say, how do I calculate that probability? Well, remember we said the total probabilities, sum of them is 1. So if we say 1 minus that, that will give you the probability that you have at least a match bit of birthdays. We can run a simulation like that, but again, that's a little advanced to what you are doing now. But this is so tedious when I have 50 people. Yeah, exactly. That's why we use something called permutation. I don't know if you heard the term or not. Oh, permutation or permutations. Okay, that will give you the number of objects selected without replacement and in order, so to speak. So you can do it with some calculators. Some will give you an overflow or infinity, but you can easily do that on Excel. So even if you don't have Excel, probably you can use like Google Sheets or any other software. And the equation you can write, in fact, I will write it and then I will give you how to do a generic one. So the probability equals 1 minus, the permutation is PERM. So permutation. And if you don't know, well, when you start typing and you see permute, so you select that. It asks how many, what is the number, meaning what is the denominator? It's 365, comma, what is the number chosen? 50. And if I do that, I won't get the answer, but because remember, this was just the numerator. Oh, I'm sorry, it froze. This is just the numerator. So I have to divide that by 365 multiplied by itself 50 times. So 3 divided by 365 raised to the 50th power. And then I close the parentheses. That would give me the probability that I at least have a match in the birthdays if I have 50 people in the room. And it turns out to be 97%. Oops, I didn't. No, it's correct. 0.97. If you want to write it as a percent, you can easily go, why do I, well, yeah, where I am. You can do a percent to get to 97%. But let's leave it, let's leave it as a fraction, but maybe with less decimal places. Now, you can see that in Excel or any other software, you can easily do the following. Of course, I'm not going to start with 1. So this is n, which is the number of people, and that's p, which is the probability that we have a match. 2, 3, in fact, you can drag down to as whatever you want. It's okay, 200. 198 is 100% for sure. But you come here and you say equals 1 minus the permutation, excuse me, oops, permutation of the number is 365 always, but the number chosen is n. And then I'm going to drag down, okay? Divided by 365 to the power of n. So I'm going to click n again. Did I close the, yeah. And that will give you only less than, it's like what? Less than 1%, right? It's 0.002, meaning 0.273%. Now, if I double click on this thing, it would fill it down. And you can see now, once we reach 23, it's 50%. See, 50.7. 3%, you go to 70%. You jump very fast. And then 40, you see 40, you will get 89%. That's a good number to bet on. And 50 that I had was 97. And then you see, once you go 60s, it's almost impossible not to get a match, right? So next time you have a big party, you can brag about, without knowing your birthdays, I know that for sure at least 2 of you share the same birthday, and they say, get out of here, we are only 50 people or 40 people, and you will win the bet. So what is the lesson you learned from that? Because I always ask my students that question at the end, and I never got the correct answer I have in mind. No, there is no correct answer. I'm sorry, this is a joke. So I never had the answer I was waiting for. I would never get it. Because the answer I was waiting for is the following. If you think you are a popular guy, okay, and a whole year pass out or elapses without being invited to 2 birthdays on the same day, chances are you're not that popular. Have a nice day. Bye.